We will go for the next example. A discrete LTI system is given by the difference equation y of n equal to this. You are asked to find h of z and indicate ROC, okay, if the system is stable and causal. Okay, so now what is first thing? Find h of z, means transfer function or system function. H of z is y of z by x of z. So first step is to find the z transform of this. Since there are no initial conditions, you need not to bother, directly go for finding the z transform without initial conditions. Okay, y of z is z inverse y of z plus z power minus 2 y of z plus z inverse x of z, which is equal to y of z into 1 minus z inverse minus z power minus 2 is equal to z inverse x of z. I have taken this on the left side, and when you take this on the left side, minus z inverse y of z minus z to the power minus 2 y of z, then I have taken y of z common, are left with this y of z by x of z, which is equal to, okay, shift this x of z on this, shift here, z inverse divided by 1 minus z inverse z power minus 2, okay, or this is h of z equal to z inverse divided by 1 minus z inverse. If you want to have the exponents of z as positive, since the highest power is 2, multiply this by and divide by h of z only to get the powers of z as exponents of z as positive. So z minus this, z inverse into z square, z divided by z square into 1, z square into this minus z to the minus 2 into z square is 1. Okay, so this is finding h of z. Now what they along with that, what they are told, and indicate ROC if the system is stable and causal. You know that if you want to know whether the system is stable or causal, you should know the poles of this function. Okay, so by using some quadratic equation, solving this quadratic equation and so on, what do you get is, okay, finding this roots, okay, z minus 1.618 and z plus 0.618, okay, using your minus b plus or minus, okay, root of b square minus 4ac by 2a, using that equation you will find these things. Okay, so what is this z? Okay, one of the pole is 1.618, another is minus 0.618. If I try to plot on this, okay, minus 0.618, this one, this is the circle of that, 1.618. Okay, so what you have done, you have plotted the poles here, okay, on this. So what they are told, indicate the ROC if the system is stable. Okay, you know that when the system is stable, okay, first condition, if the system is stable, what it should be, it should consist of unit circle. Okay, when the system is stable, it should consist of unit circle. So when it consists of unit circle, this is minus 0.618, which is covering plus 0.618 also, and this is 1.618. Where is your unit circle? A circle with radius 1, somewhere here, right? So now if this is the unit circle somewhere here, okay, ROC, the system, okay, this is your answer. The system, okay, is said to be stable when it consists of unit circle, means your ROC should be, okay, lying between minus 0.618 z less than 1.618. Okay, this is your ROC, right? Means z less than 1.618 and greater than 0.618, that is your ROC. Okay, how it should happen. Next, second, causal. Causality, a system is said to be causal when ROC is exterior to the circle. Exterior to the circle means, okay, this is your last pole 1.618, this is 0.618, inner circle, outer circle is 1.618. It should be exterior to the circle. If you tell exterior to 0.618, then it will include this pole, okay. But if you tell exterior to 1.618, then it will serving the purpose 1.618. okay. So these are the things, okay, how you have to write the ROCs with respect to stability and causality. Okay, when Z is greater than 1.618, plot it and show exterior to the circle. When Z is lying between this, okay, I have shown the poles. You have to just here for stability I will show you. Okay, it is lying between this. Okay, lying between 0.618 and 1.618. Okay, for Z greater than 1.6, draw one more graph, show two circles and exterior to that. Okay, this is how you are going to plot the ROC with respect to stability and causality. Okay, I'll take another form of example. Okay, a LTI system is described by y of n is equal to x of n plus 0.81, x of n minus 1 minus 0.81, x of n minus 2, okay, minus 0.45, y of n minus 2. They have asked you to determine, okay, determine transfer function. Okay, so which is equal to, you know the transfer function means h of z, or system function means this, means you want y of z divided by x of z is this. Okay, so how to calculate this? Okay, how to calculate this? So finding z transform of this, y of z is equal to x of z plus 0.81 z inverse x of z minus 0.81 z inverse z to the power minus 2 x of z plus minus 0.45 z to the power minus 2 y of z. Okay, now y of z, this you take it here 0.45 z to the power minus 2 y of z, which is equal to, okay, x of z plus 0.81 z inverse x of z minus 0.81 z to the power minus 2 x of z. Okay, take out y of z common, 1 plus 0.45 z to the power minus 2, which is equal to x of z take out common, 1 plus 0.81 z inverse minus 0.81 z to the power minus 2. Okay, that is equal to y of z divided by x of z is 1 plus 0.81 z inverse minus 0.81 z to the power minus 2 divided by 1 plus 0.45 z to the power minus 2, which is equal to h of z. I will try to write positive powers, z square plus 0.81 z minus 0.81 divided by z square plus 0.45. Okay, this is determining transfer function.